At Cornthwaite High School, many students enroll in an after-school arts program. The program offers a drama class and a music class. Each student enrolled in the program is in one class or both classes. This year, 41 students are in the drama class, 28 in music. If 15 are in both, how many students are enrolled in the program? So in these questions, we're going to do something known as a Venn diagram. And some of you know what it is, but some of you don't. That's not a problem. I can explain it. So the first circle I drew represents the drama class, and the second circle I drew represents the music class. And I will write the letters A, B, and C to represent the number of students in each of those categories. So A represents how many students are in drama, only drama. B represents students that are in both drama and music. And C represents the students that are only in music class. So let's look at the numbers they gave us. 41 are in drama. So that means A plus B is 41. 28 are in music. So that means B plus C is 28. And 15 are in both. Okay, good. So B is 15. So that can help us easily solve these. B is already given as 15, so we can plug that into this guy to get A. A would be 26, I believe. And plug B is 15 into there to get C is equal to 13. And then what they want is the total number of students. So what they're asking for really is A plus B plus C. Well, no problem. That's 26 plus 15 plus 13. And that is 54. In 2014, a total of 80 students enrolled in the program. 3x minus 5 students were in the drama class. 6x plus 13 students were in the music class. And x students were in both. Determine the value of x. Same story. Let's do it again. And same thing, A, B, and C. This circle is representing drama. This circle is representing music. Okay, so a total of 80 students. So we are told that basically all the students is 80. So that means A plus B plus C is 80. And then they tell us that 3x minus 5 students are in drama. So that means A plus B is 3x minus 5. And they tell us that 6x plus 13 students are in music. So B plus C is 6x plus 13. Okay. And anything else? Okay, got it. X students were in both classes. I almost missed that. So X students, so B is X. Okay, so same story. The only difference is that this time we have X instead of numbers, but not a problem. If we plug B equals X into this guy right here, we can solve for A, and that makes A is equal to 2x minus 5. And very similarly, if we substitute B equals X into there, we will get C is equal to 5x plus 13, I believe. Yeah. Okay, so what are we trying to figure out in this question? Determine the value of X. So I guess we just plug everything into there. So A is 2x minus 5, B is X, and C is 5x plus 13, and that all equals 80. So this is the algebra. This becomes 8x plus 8 is 80. Divide through by 8, and you get x plus 1 is 10, and therefore x is equal to 9. In 2003, half of the students in the class, drama class, were in both classes, and 1/4 of the students in the music class were in both classes. A total of n students enrolled in the program in 2013. If n is between 91 and 95 inclusive, determine the value of n. So same story here. But before I put in some letters, well, I put in the letters. Let me just put in the letters initially, but let me put some numbers. Let me make a different diagram, but same diagram, but with numbers that I just sort of make up to illustrate it. It might be a little bit easier to understand. So half the students are in drama. Half the students in the drama class are in both classes. So, for example, if let's say it was 100 students in the drama class, half of those would be in both. So if drama was, say, 100 students, then half of them, and this isn't drawn to scale, but that's okay. So that would make sense, right? 50-50. There's 100 students in the drama class. and half of them, which is 50, would be in both classes, and that's why the 50 goes in the middle. And let's do the same thing with the quarter music story. 1/4 of the students in the music class are in both classes. So that 50 represents 1/4 of all the students in the music that are in music. So that means this would be 200, because 50 represents 1/4 of 200, and that circle would have 150. So I just did that to kind of show what the sentences in the question are referring to. I think it'd be a little bit easier to understand with numbers instead of just letters. Now, since we are an expert with numbers, let's move over to letters. As we saw there, those two numbers are equal. So that means this B is equal to A, and that A is equal to B. Got it? And as we saw here with that, this C is equal to 3A. Got it? And that's drama and that's music. So I think this part is a little bit easier to understand now that we had that. Okay, so we are told that the total number of students, which is AB plus C, is N. And that N is between 91 and 99. Okay, so let's see what happens. I guess we just substitute everything in for one variable. So B is equal to A and C is equal to 3A. So there we go. So this would be 5A is N. So that basically means that N is a multiple of 5. And the only multiple of 5 in that range, you tell me, is N equals 95. That's it. No other number in that range would be a multiple of 5 except 95. Alistair, Conrad, Emma, and Salma compete in a 3-sport race. They each swim 2 kilometers, then bike 40, then finally run 10K. Also, they each switch instantly from swimming to biking and from biking to running. Emma has completed 1/3 of the total distance. How many kilometers has she traveled? Well, the total distance is 2 plus 40 plus 10, which I believe is 52. So 1/13 of 52 is just 4, exactly. So 4. She has traveled 4 kilometers. Conrad began the race at 8 a.m. and completed the swim portion in 30 minutes. Conrad biked 12 times as fast as he swam, 3 times as fast as he swam, ran 3 times as fast as he swam. What time did he finish? At 8 a.m. to, let's see here, 30 minutes, so 8:30 is when he finishes the swim. And that, okay, we got to figure that out. So it was 30 minutes for 2 kilometers, right? So 30 minutes for 2 kilometers means in 1 hour, 4 kilometers. So 4 kilometers per hour would be the speed that he swam at. So swimming. Okay, and then 8:30 till something, but he's biking now, and he's biking 12 times as fast. So 12 times 4 is 48. So 48 kilometers an hour is how fast he bikes. And the bike is 40K. So that would be 40 divided by 48 is in terms of time. And I believe that is that's 50 minutes if you convert it to minutes. So 8:30 plus 50 minutes is 9:20. That's when he finishes the bike. And then running, which is my favorite activity, is 3 times as fast as he swam. So that's going to be 4 times 3, which is 12. 12 kilometers an hour. So the run is 10. So 10 divided by 12, and again, that's 50 minutes. So 9:20 plus 50, and that's going to be 10:10. So 10:10 is when Conrad finishes the race. Alistair and Salma also began the race at 8 a.m. Alistair finished the swimming portion in 36 minutes and then biked at 28 kilometers per hour. Salma finished the swimming portion in 30 minutes and then biked at 24 kilometers an hour. Alistair passed Salma during the bike portion. At what time did Alistair pass Salma? Okay, so let's first write this down. So it's 8 to 8:36 for Alistair, I believe. Yeah. And then 8:36 and then onward. well, let's see here, 28 kilometers an hour, and the bike is 40, right? 40 kilometers. So this, if you convert it to minutes, it's 1 hour, 25 minutes approximately. I think probably a little bit more than that, but let's just keep it at that for now. So that's going to be 10:01, I believe. Okay. And then Salma, she starts at 8 just like the other guy, but she finishes in 30 minutes. And then she's going to be on the bike for the same kind of distance, but her speed is a little bit different. It's 24. So that is going to be 1 hour and 40 minutes. So she's going to finish 10:10. Okay. So then obviously Alistair passed Salma during the bike portion because he finished about 9 minutes earlier. So we have to figure out at exactly what time did he pass. Okay. All right. Let's see what I can do here. Interesting. Well, let's say that T is the time that Alistair passes Salma in minutes, because I think we're going to have to make sure that we keep the units the same. But what's interesting is that they're not starting the bike at the same time. They start the race at the same time. So let's start the clock at the same time. So for Alistair, it would be T minus 36. That's when the clock starts for him. And for Salma, it would be T minus 30. That's when the clock starts for her. Okay, so then now, from the 8 a.m. start, we can kind of see what happens. For Alistair, his is 28, right, in terms of his speed of biking. So 28 times T minus 36, and then we got to divide by 60 minutes because we are talking in terms of minutes, and this is kilometers per hour. Got to make sure they're. And since they meet, when they pass each other, they're meeting for a brief period. That's going to be equal to Salma's story, which is 24 kilometers an hour, T minus 30, and also divide by 60. So I'm pretty confident that that's the algebra. And let's see what happens when we solve for it. The 60s go, so this is going to be 28T minus 28 times 36. It's going to be 24T minus 24 times 30. So that means 4T would be 1008 minus 720. And then when you solve for this, you get T equals 72 minutes. So at the 72-minute point is when Alistair passes Salma. And just to clarify, this is 72 minutes since the start of the race. So since the race started at 8 a.m., this would be at 9:12 a.m. is when they pass, I guess, or meet. Heron's formula says that if a triangle has side lengths ABC, then its area is equal to the square root of S times S minus A times S minus B times S minus C, where S is A plus B plus C divided by 2, which is the semi-perimeter of the triangle. In the diagram, the side lengths are 20, 99, and 101. If H is the perpendicular distance from A to BC, determine the value of H. Well, the semi-perimeter would be 101 plus 99 plus 20 divided by 2, and that is 110. So Heron's, the area would be the square root of S, which is 110, times 110 minus 101, times 110 minus 99, times 110 minus 20. And when you crunch out all those numbers, you get 990. All right, so the final step is to figure out H. Well, the area can be written as 1/2 base times height, where the base is 99 and the height is H. But the area we already figured out was 990. So there you go, 99 over 2 times H. And when you crunch out those numbers, you get H equal to 20. Part B. In the diagram, trapezoid PQRS has PS parallel to QR. Also, PQ is 7, QR is 40, RS is 15, and PS is 20. If x is the distance between parallel sides, PS and QR, determine the value of x. All right, so what I'm going to do is first drop some perpendiculars like that and break it up into a triangle, this triangle, the rectangle, and then that triangle. Now the rectangle is a 20 by x, so that area would be 20 times x, correct? Now this triangle here, this one and that one, I'm going to combine them. I'm going to put them together. So let me just put them together. You see what I'm saying? I kind of put them, connected them. And then that's 7, that's 15. And this distance, let's call x, this distance call y. So that's x and that's y. Now, this distance all the way in the bottom was 40. And from here to here was 20. So that means that x plus 20 plus y is 40. And therefore x plus y is 20. So this distance, x plus y, is 20. So look at that. I made a little triangle with 3 sides where I can use herons. Correct? So let's figure out the area of that using herons. So first I have to figure out the semi-perimeter. So it'd be 7 plus 15 plus 20 divided by 2. So that's going to be 21. And then using herons, it would be 21 times 21 minus 7 times 21 minus 15 times 21 minus 20. All the square root, and when you crunch out those numbers, you will get 42. So the area of that whole thing would be the 20x plus 42. Correct? Okay, we still have to figure out x. Now, this is a trapezoid, so the area of a trapezoid is, using those numbers, would be 20 plus 40 all over 2 times x, using the trapezoid area formula. So that's going to be 30x. So there we go. Area is 30x. Area is 20x plus 42. Let's set them equal to each other. So 30x plus 20x plus 42. Oops, that should be equals. And that means 10x is equal to 42. And therefore x is 4.2. The triangle with side lengths 3, 4, 5 has the following 5 properties. Its side lengths are integers. The lengths of its 2 shortest sides differ by 1. The length of its longest side and the semi-perimeter differ by 1. Its area is an integer and its perimeter is less than 200. Determine all triangles that have these 5 properties. Let's go one by one and see what we can do here in terms of a math. All side lengths are integers. So I'm just going to call them A, B, and C. And we're going to put A less than B less than C. Yeah, I think that's sufficient. The length of its 2 shortest sides differ by 1. So we can say that those 2 shortest sides are A and B, and they differ by 1. So A plus 1 is equal to B. The length of its longest side and the semi-perimeter differ by 1. So if S is the semi-perimeter, it would be C plus 1, because C is the longest side. And then the area is an integer, so the area is an integer. I'm not sure what else I can write there. And the perimeter is less than 200. So A plus B plus C is less than 200. Okay, so that's basically just converting words into numbers or words into something. Okay, so now let's work with this. So we have some triangle here, and it's got sides A, B, and C. Okay, semi-perimeter is A plus B plus C over 2. Okay, B is A plus 1. I'm just trying to see what I can do here. This formula here that I just drew, S is C plus 1. and then a plus b, which is a plus 1, plus c over 2. So this is 2c plus 2 is 2a plus 1 plus c, and therefore c would be 2a minus 1. Okay, so c is 2a minus 1. It's moving right along here. And therefore s would be a plus b, which is a plus 1, plus c, which is 2a minus 1, all over 2. And that looks to me like just 2a. Okay, so that's a pretty decent start, I think, I hope. Now, where do we go from here? Let's see here. So far, we're doing good. What have I not taken into consideration yet? Obviously, I've taken into consideration this guy, and this guy. So the next two, the area and the perimeter. Well, the area, a plus b plus c, is less than 200. Oh, sorry, that's the perimeter. So a plus b, which is a plus 1, plus c, which is 2a minus 1, is less than 200. So that's what? 4a is less than 200. So that means a is less than 50. Okay? That's another hopefully helpful finding. And then now, finally, let's tackle area. Now, area, I'm pretty confident we're going to be using herons, since this entire question is about herons. Okay, so the area using herons would be s times s minus a, s minus b, s minus c, all under the square root sign. Well, my s is 2a. We got that up there. And therefore, this would be 2a minus a, 2a minus b. But b, I'm going to use the fact that it's a plus 1. So it'd be minus a minus 1. And then a c, I'm going to use this fact. So minus 2a plus 1 when you subtract it. Okay, so this, let's see here. 2a, a minus 1, and just 1, okay? So this becomes, let's see here, 2a squared times a minus 1. Let me just put the a squared by itself, and then this 2a minus 2 like that. And then if I take out the root, it would be just a, and then 2a minus 2 like that. Okay, so that's the area. Okay, so, and this has to be an integer, because remember, that was the property, this guy right here, that a is an integer. Well, the only way this can be an integer is if this guy is an integer right there, because a is already an integer, we know that. So we have to concentrate now on making 2a minus 2 under the square root sign an integer. For, let's see, what values? What values of a? Well, that happens if 2a minus 2 is a perfect square. If 2a minus 2 is a perfect square, then the square root of it will be an integer. And another very important point is that 2a minus 2 is even. Also even. So it's a perfect square and it's even. So we have to figure out all the perfect squares that are even, but we are given a parameter. That's a very important parameter, that a is less than 50, so that helps us out a lot. Because if a is less than 50, and also a is an integer, so it has to be at least 1, then if you multiply both sides by 2, we get 2 is less than 2a less than 100, and then if we subtract 2, we get 0 is 2a minus 2 less than 98. So this is between 98, well, less than 98 and greater than or equal to 0. And it's a perfect square, and it's even. So we got to list all the perfect squares that are even between 0 and 98. Okay, so I believe that's 0, 4, 16, 36, and 64. I think those are the only numbers between 0 and 98 that are both perfect squares and even. And these are, of course, corresponding to 2a minus 2. When you solve for a, let me just write that here. These are the 2a minus 2's. When you solve for a, you get the following values. You'll get 1, 3, 9, 19, and 33. Yeah. Okay, so then now, since we know the ABC is right here, A, B, and C is A plus 1, and 2A minus 1. A plus 1, and 2A minus 1. We can figure out the triangles. So ABC is A plus 1, 2A minus 1, correct? Okay, so using these values for A, let's see what we get. 1, 2, and 1. That's for this guy. And then we get 3, 4, 5. That one has already been given for this. For the 9, we'd get 9, 10, 17. For 19, we'd get 19, 20, and 37. And finally for 33, we'd get 33, 34, and 65. And of these, this one does not satisfy the triangle inequality. You guys remember that, right? Triangle inequality. Because if you have a triangle like ABC, A plus B has to be greater than C. And that's the only way a triangle can be made, and that 1-to-1 fails that. But the other ones all pass it. So these guys are good. So those are the answers to the question, which was determine all triangles that have those 5 properties.